Graphing a piecewise defined function, problem type 2. Suppose that the function f is defined for all real numbers as follows. The function f of x is in two pieces. The first piece is x minus 3, given the domain to be what? X is less than or equal to 2. The second piece of the function is negative 5x plus 4, given the domain for that is x greater than 2. So why don't we graph these pieces separately? I'm first going to graph this with a dotted line, and then I'm actually going to make it solid to match the appropriate domain. So why don't we graph x minus 3 as a dotted line first? So you could use slope y-intercept form, so you could actually notice that negative 3 is down there on the y-axis, and then the slope is 1, so it's going to increase with a slope of 1 from right to left. And so I'm going to draw it with a dotted line like that. Remember, it's slope of 1, so all you have to do is go up 1, right 1, up 1, right 1, and plot another dot. So now what is the appropriate domain? X is less than or equal to 2. So when do we make this solid? Right about here. And if you have a straight edge, go ahead and use it. I'm just using the graph. And then I'm going to erase the rest of the dotted portions. So I'm going to take an eraser here. Bloop. And then it is included. You're including the input of x equals 2. So we're going to make a nice big solid dot right there. And if you want to, it's better to even label that. So let's label that 2, negative 1, so that we know we got the first piece of the function. Let's take the second piece of the function, which is negative 5x plus 4. That once again graphs a straight line, but this time we got to look at that domain right there. Once again, I'm going to first graph it with a dotted line. So the y-intercept is 4, so we're going to need to plot a point at 0, 4. And then we're going to go down 5, right 1. So there's a dot at 0, 4, and then we're going to go down 5, 1. Here, we're going to go down 5, 1, 2, 3, 4, 5, and then right 1, and plot another point right there. What is that? That is actually 1, negative 1. Right there. I'm going to draw it dotted. Here, let's see if I can use a straight edge, make things a little bit neater. So I'm going to use my straight edge here this time. And we're going to just draw this dotted. Let's see here. Come on, straight edge. Straight edge, where are you? Straight edge. Here we go. Dot, dot, dot. Dot, 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 dot. Oh, I don't want too many dots here. Okay. Now, what is the domain? The domain says x greater than 2. So it's really right about here. And I'm going to fix some of my labeling here. I'm going to fix this label. I'm going to put this label here, 2 to negative 1. And let's get a nice eraser here. Let me erase some of this. Erase that part. Okay. Here, I'm going to erase this part as well. That's actually 2, negative 6, whereas where I got my first blue dot. My first blue dot is 2, negative 6. If you don't believe me, plug in 2 right here. What happens when you plug in 2 right there? Excuse me. Let's see. I was going to say, if you don't believe me, you could look off to the side. This is scratch work. If you plug in 2 in the second piece of the function, you end up getting negative 6. right, so our first blue dot is actually at 2, -6. And we're just going to draw a straight line going this way. Ah. Now we go back and you make things neat. Erase the dotted line. And there you go. This is a piecewise function. For every x, there's exactly one y. It passes the vertical line test. And there you go. You got two pieces of the function on its appropriate domain. Is the function continuous? In other words, can you keep your pencil on the paper tracing these functions? Is it possible? And the answer is no, right? There's a jump. There's a jump at x equals 2. Does anybody see a mistake? I believe I made a mistake. I said for every x, there's exactly one y. Well, right here, there's an x with two y's. That can't happen. So let's fix that. What was the mistake there? You got to make sure you read the domain very, very carefully. It says x is greater than 2, but we don't include 2 here. So what happens then is we create this nice little hollow dot. So I made a mistake earlier. My first blue dot is not at 2, -6. The first blue dot is right after that. And there's an infinite number of blue dots down there. There's an infinite number of blue dots down here, and that represents the second piece of the function. All right, well, circle your final answer. And we already said that this is not continuous because you cannot keep your pencil on the paper while tracing this function. So it's not continuous. So you could circle this one as well, or you probably bubble it.